Conductive Labs released 2 instruments on Kickstarter. And there is a lot to talk about the design process of the Noodler that you might have seen before, or their MIDI port device that, I forgot the name, MIDI Router Control Center, MRCC in short. What's interesting about these 2 products, the Noodler and the MRCC, is 2 things. First of all, the design is very unconventional and solves a lot of problems that you might not even think that you have as a musician. And the second thing is that they actually did everything from home, and they are building instruments now as a manufacturer in China. They've been doing this for the past 2 years. They've been working on this for, I think, close to 5 years now. And there's a lot that Steve is generously sharing with us about this process, about designing something, creating a prototype, getting to the point of Kickstarter, and from there getting to the point of realizing we actually need to manufacture this completely in China. And what are the things you need to be aware of when you're taking such a step to build so much stuff and to ship it around the world. So all the way to pricing, we cover everything. This is why this podcast is much longer. I think it's close to 2 hours, and I hope you're going to enjoy it. Let me know in the comments below, and please like and share, because that's how the internet works. I really appreciate it. This is Conductive Labs, and I'm Roy, the Synth Academy, the Synth Design Podcast.
Well, the Noodler was born out of need. So Daryl, my business partner, and I, we both retired. We've been longtime friends, and we were both employed at Intel, and we retired at the same time. And we were both, in addition to being friends, we were both kind of synthesizer nuts. And we started egging each other on to buy stuff on Craigslist, and slowly but surely, the little 19-inch rack that held one device needed to get populated, because you get that sort of feeling that you need to fill all your rack space and so forth. And next thing we knew, we had, numbers of synthesizers, 5 to 10 each. And neither he or I can play keyboards. And so I'm frustrated because I have these synthesizers. They all sound great, some better than others, of course, but I can't get them to all make sound at the same time, right? It's like I had a sequencer, and it would play monophonically one synth. And then I got a better sequencer. I probably got the Key Step and then a Beat Step Pro. And then the Beat Step Pro can play, more than one synth and polyphonically. But I also play guitar, and not great, but I play. And I had a lot of experience with music theory back in the day in college. I got a minor in music for composition. Mm-hmm. And so I understand a little bit about chord progressions and about staying in the key and what modes are and all this stuff. And the music was so boring to me, because even with the guitar, when you're just first learning, you learn 4 or 5 chords, and you got your lyrics, and D, F, A, D, F, A, and you strum along and you sing. And it's like I couldn't play a D, an F, and an A on a sequencer. I couldn't physically do it. And I looked around and I thought, surely somebody's got to be able to do this. I mean, just an auto harp can even do it, right? So I started building this idea in my mind about building a device that allowed me to just choose the chord degrees in a key. So in the key of C, I will get into theory just a little bit. In the key of C, you have C major, and then it's D, major, minor, minor, major, major, minor, diminished is how the chord goes as you go up in chord degree. And a simple concept like that didn't exist anywhere in a sequencer that I could find. Mm-hmm. And so that's sort of what the birth of the idea came from. Is we both had these synthesizers. We had a couple of sequencers that we were trying to do stuff with, but the desire to want to play a song with chords, pressured us into this idea of, well, maybe we could make a box that does that. That was the first inkling of that. Right. And then couple that with So I'm a visual and audio learner, and so I'm on YouTube watching all these videos of how to do this and how to do that, and I stumbled upon the website Notes and Volts,
Mm-hmm.
and there's a guy named Dave that does that show. He's a really great teacher. He goes very slowly and walks you through what you need to do to build devices with Arduinos, and the source code is there. And he walks through the wiring and why you have to do this, that, and the other thing. And it was simple enough that I could just watch it and figure, wow, that's easy enough to do. And I had an Arduino I'd never opened up. I had bought it for a project to do with my Lego hobby. And so anyway, I brought it downstairs. I called Daryl and I said, hey, man, you got to come over. And we, within an hour or two, had that Arduino board plugged into probably a microbrute, and it was bing bong bing bong bing bong, and it was making noise. I'm like, holy shit, we can make stuff. and I was so excited. It was like, this is the coolest thing ever, because the last time I had done that was like in 1984 with my Commodore 64 and its little and the sound synthesizer inside of it, where I actually had programmatic control over the notes. Yeah, so we started on a different project at first. It was a controller, and then we figured that wasn't viable, but we learned a lot about how to make encoders work and buttons and LEDs and things. So then we decided, well, that idea that we were talking about how to make a box to play chords for us was the right project to work on. Yeah.
Right. So when are we talking about? When was this?
This was for, what month is it? Yeah, just a little over 4 years ago.
Right. And before that, you worked at Intel as a programmer, or?
No, I was, both Daryl and I had similar jobs. It was called technical marketing. So it was a type of job where you would interface between well, there are a lot of different types of jobs in that category. But one was, if you have customers and you've got an engineering group, you typically don't want engineers to talk to your customers. This is right out of that Office Space movie, right? I'm a people person. It was that guy's job. Literally, that was the funniest thing I ever seen in my life. So yeah, literally, you'd go visit customers and you'd figure out what their requirements are. And you would also know how to operate whatever it was the project was based on. And you would teach your customers this. We'd go to conferences and do classes at shows and conferences like CES and Comdex and things like that. And then also visit with customers.
Right.
But, it might be interesting to take a couple minutes. So during my career there, I was brought into a group called PAPR, which is called People and Practices Research.
Right.
And unbeknownst to me, this was where my world opened. So, I was always in these technology groups. I always thought of myself as a technologist, and I was in the architecture development labs at Intel where, guys like 2 cubes over from me invented USB, literally. So there was all these new technologies going on, and I would be the one that would make demonstrations of these technologies in various ways, either take stuff that was already in existence and put them together in a way that people could understand. So when we'd go to trade shows, we could show it off, or I'd write a little bit of code to do it. But I got into this group called PAPR, and my job was to be basically the demo guy or the concept developer. But what I didn't understand was that I was joining a group with a bunch of really wicked smart PhD anthropologists. And these guys taught me what user-centered design was all about. I had no idea. And we did some wild things. So, I would go out with an anthropologist and we had teams. We'd reconfigure these teams, but they were teams of 2. And for a certain project, we would go to a certain location and have some folks lined up where we would literally stay with them for like 8 hours straight and just mirror them throughout their whole day and figure out what they were doing and how they were doing it and where the trouble points were and where their aspirations lived and all this, what I would call back then highfalutin thinking, right? And then the next day we would, that night we would go back and this is where these guys would do their hard work. They would figure out a bunch of stuff and look for trigger points throughout this person's day.
Mm-hmm.
And then we would go and dig deeper the next day on their trigger point. I mean, we would, like, of course, with their permission and everything, but we would open up their trunks of their car and pull everything out and inventory the trunks of their car and their dashboards and what was under the seats, just to sort of know what goes on in people's lives inside of their car, as an example.
Mm-hmm.
We did an this was in the day when MP3 players were just starting. And so we did a music study where we just went to people's homes and just learned everything about their music habits. And through their actions, right? Not through. Well, you could also learn. This was a great point. So we would ask them questions like, "So how many MP3 players do you have, or how many music devices that play music do you have?" And they would say, "Well, I got this and that." They would say, "Oh, I got 8." And then through the brilliance of these anthropologists, they would say, "So right now, how many of those devices could you turn on and play music, and are there like fresh batteries in there?" And they would go, "Well, no, 2." Right? So, I was kind of learning, I was getting what they were doing, right? So people will aspirationally tell you what their desires are. I've got 12 devices that play music, right?
Yeah.
But you learn that only 2 of them really, really work, right? Because otherwise there'd be fresh batteries in all of them, right? So there were these ways of getting to and it's not about calling them liars or anything like that. It's just understanding the difference between how people perceive themselves and perceive their desires, and how they want other people to perceive them through those actions. And it was just all these wonderful.
Yeah, it's I wouldn't say it's an art form, but it's a very technical thing to know what questions to ask.
Yes.
Because what happens is you have an assumption. For instance, with this research you just described, the assumption is, I think that there are not enough intuitive instruments players that they have, and then they ask how many they have, and like, yeah, I have 8, but how many of them do you actually use? Then they might also give a different answer. But if you're asking how many have fresh batteries in, then right away you get to the answer. That's a very clever way of like asking the right question to find out. Yeah. It's not like a lot of people think that the user experience, like research, is about asking, do you like this? It's not, like, people don't really know what they like or they don't like. You need to kind of sense in between the lines what they are interested in, because you have an assumption, and sometimes it's very confusing if you are the user, which many of us are, because, we're into music, or we're playing music, or we're building stuff for ourselves in whatever way of shape and form. And then we think we know all the different problems that that a person is going to face. Right. But then when you start like challenging yourself, and you're saying, what if I would ask, like, this person is playing sort of like me, I think that they're sort of like me. I think then you start getting to a whole new level of interaction. You can create things that would puzzle you, because you're like, you didn't think about it. It becomes a collaboration between you and a group of people that are sort of like you. And it's the little details that you're adding into, like, for instance, the MIDI controller that you just came out with. Yeah. There is this thing with the jacks that, there is this adapter, and like, I looked at this, I was like, this is brilliant. This like not needing the adapter and just having this right is fantastic. And the only way to do this, to understand this, is to really like face this problem and understand this can be solved in a better way than having these adapters.
This guy, which there's different colors, because in the brilliance of the MIDI association, they came up with 2 flavors of this. Fantastic,
because you need them, because
but then you never know what you always have. Well, I think there's actually 3, because Arturia came up with one that's for DIN sync, which uses the other 2 pins on this side, and it's like, so there's 3 of these cables, and you can never figure out which one the right one is.
But so that is very interesting. In that sense, you actually had quite a bit of an experience with user-centered design.
Well, if I can continue. So we would
Yeah.
come back to the plant after that 2 or 3 day visit.
Mm-hmm.
And we would record a lot of video while we were doing this. We would make video as we were shadowing them, video of the interviews, video of going through all their stuff. And then we came back and had large team, a dump to the team. And then we would go into the design phase of where were the points that deserved to be looked at. Mm-hmm. And one of the points, if I recall correctly, was physicality, because this was the transition going from CDs to no CDs. And there was a visceral physicality of, I want to hold that out. Well, it used to be an album, right? And then it was a CD or a cassette, right? Prior to that. But then it went to nothing, right? There's all of a sudden, I've got this device with 10,000 songs on it. I don't know how to get to the song. I don't even know how to, there were things like some people are visually provoked to listen to music by, they would sit, we'd have video of them sitting on the floor going through their record collection with their finger, right? And it's like, and you could watch their face. They would get to a record and their face would just light up and it would pull it out, right? And so there was this physicality of remembering. Mm-hmm. And so as an example, to take this all the way through to its logical conclusion, and I'm not saying that what I came up with was anything special, but that physicality then demanded, why they had guys like us in that group was that we would then come up with an idea to express what physicality might be in a digital music world. Mm-hmm. So I came up with, the little photo, like a photo tree where they've got the little clips on them and you can clip the photos onto them. Yeah. So I took a photo tree and I made a bunch of album covers that looked like about the size of a business card. Okay. And I clipped like 20 of these. I printed them out, cut them out. This was like literally with scissors, right? And back then, this was a long time ago, I put barcodes on them because there was no other way to. We were playing with those tags. What's a G? I can't remember the sensor, the sense at a distance tags. GPIF? I can't remember it. No, that's a light socket. Anyway, and they never seemed to work right. So we decided to use barcodes. But so, you had this display of all these fingers holding and you could visually see your album collection. Yeah. And then you would unclip it and swipe it across this little electric eye. And all of a sudden that playlist would start playing through your stereo. So you didn't need to put it into something and play it. But the nature of the physicality of that album was maintained, right? And it was, again, it wasn't to be a product. It was just to evoke the notion that a physicality could be important to people in a world in which we're going down the path of no physicality. Yeah.
And I could dive into this conversation for like hours to just talk about this because I'm collecting like really only special editions of vinyl. But let's put this aside. Sure. What I'm curious to know is how does this take you? How does this apply to the products you're making today?
Right. So just having a background in this methodology, it just helps you understand how to ask yourself the right questions. Like, why am I? Like we were talking about the noodler. I'll get back to that. So, first of all, it helps you think about what is, I'm looking over here because I'm staring at a noodler sitting here on my desk. Makes you ask the question, okay, so how am I going to use this device? Am I going to use it to make pre-recorded music, or am I going to use it for live playing? Just having that background allows you to explore these questions so that when you're defining what the knobs do, you're always in a context, or at least can ask the right questions about, okay, so I'm going to be in more of a live context. And in fact, the noodler is aptly named. We named it the noodler very specifically because it's not supposed to be a composition tool, and it's really not supposed to be a live jamming tool, although it can be used for that stuff. The idea was, our user need was, in fact, here's a user story, right? The user story is, I have all these synths. I come home from work and I've had a hard, long day, and I really don't want a computer in front of me because that's what I did all day long, right? So I forgot to mention that we went through the DAW, having the DAW in there. I mean, both of us worked at Intel, right? So we kind of know how to use computers and stuff. The DAW was, it was the craziest. Both of us gave up at about the same time. We literally went at it for about a year. And every time I went into my music room and tried to open up the DAW and try to create some music, it just turned into me becoming an IT person and not a musician. And both of us at the same time said, you know what, we got to get this thing out of our room. So that was another predicated notion, is that the Noodler was going to not necessarily replace a DAW, but if you don't have a DAW around, what do you do, right? That's why I was stuck with the sequencers. That's how I got to that point, right? So we removed the DAW, replaced it with a sequencer. Anyway, back to the story about the Noodler. So the idea was, you come home from work, you're tired, you don't want to deal with a DAW and be an IT person. You just kind of want to, it's the popping open a beer version of playing music. I just want to drink the beer and sit back and just relax, right? So the Noodler, the idea of the Noodler was, I just want to turn the thing on, I want to press a button, and I want my synths to sort of just kind of come alive. And now, optionally, I can go turn knobs to change the timbre of my synths or the patches. And I can twist some knobs on the face of the Noodler to make it more evolving, so it's not boring, right? And that was the idea. It's like sitting with a guitar when you come home from work. You're not there to try to compose a song necessarily, or perform to an audience. You're there to just relax. You're going to play some music just because the act of playing music, puts you in a different headspace. It's incredibly healing to play music from a hard, long day at work, right? It's got its healing nature. And so that Noodler was supposed to be that sort of thing, the thing where you can just come home from work, turn on your synths because you like that sort of sound, and just press these buttons like you would strum an auto harp to just sort of enjoy making music.
Yeah.
And so the idea of the Noodler keeping you in key and in mode and not sounding like an industrial garbage can rolling down a hill was part of the notion, was that you can get into some funky places with the Noodler. They're not all diatonic based stuff, meaning friendly, nice music. You can get into some atonal stuff if you go find it, right? But one of the design notions, and we kept asking ourselves when we were designing what the knobs do, is how we wanted to make it so that it stayed diatonic most of the time, and you had to work to get it out of being diatonic. Again, because the notion was it was supposed to be a fun thing to just come home and noodle, like on a guitar. They call it noodling, right? That's the whole idea. That's why we called it the Noodler. It was the synth version of that.
Yes. So that is an interesting notion, that you're saying the instrument is supposed to be diatonic. If you want to search for the more experimental composition space, you can do that, but it's not really designed for this.
Correct.
And this opens a whole world for performers who don't really know much about music theory. Basically, you just open it and it works.
Correct.
And then you can dive in. I mean, I can see myself without with no hardcore theoretical knowledge playing with this, but then also creating sort of designing it to play a performance for me.
Sure.
Not completely generatively, but in a way that I'll be able to move around and create an hour of a show, especially for the melodical parts.
Yeah, absolutely.
Just like with a drum machine on the side, and then this would just run everything that I had in mind that I composed. And it's like an instrument that for a composer would allow to tweak and direct the conversation or the performance into where they want to go.
Yeah. And
what I find tricky in a project like this is that there's definitely feature creep.
Yeah.
There's so much that goes into it that at a certain point it becomes really, really like when do we actually release this to the world? So
Yeah.
can you think about the first moment that you felt like, okay, this is maybe too much. We need to cut some parts out to be able to actually move forward with it?
Yeah. Well, I wanted to go back and just say one other thing. The name of our company was synonymous with this first product, as normally it is, right? You come up with a product idea and then your company name. And Conductive Labs has two meanings, right? It's conductive, meaning like electronics, but it's also conductor.
Oh, right.
Cool. And if you look at the Y, there's a T in conductive, and we use a Y with a little head in there. So he's got like his hands up.
Yeah.
When the font's really small, there's no place to put the baton. But if you look at our box, that Y guy is holding a baton.
That's cool.
So he's actually the conductor. And,
that's cool.
And that's kind of the position of the user for the noodler. That was the idea, that you're conducting this sort of band instruments. Okay.
That's a nice touch.
Yeah, thanks. So feature creep, let's see. Well, this might be a good time to take a look at the user interface design.
Please
sketches.
Go ahead. Sure.
So let's see, I'll pop open. Let's see, I do the share screen. So this is, okay, so I have some weird, I'm an electrical engineer by schooling. I have a degree in electrical engineering. I was one of I graduated in 1990, and I actually have it's an electrical engineering degree, but it's an analog electrical engineering degree, which is like the last year they did that. Then the school sort of went digital, which they should have done. So I spent my world learning this insane mathematics for analog electronics. And the sad thing was, it scared me. It scared the crap out of me. I was hung on by my teeth to get through that program. And when, of course, I got the job at Intel right out of college, I was super excited, because at that point, 1990, Intel was the top of the world. And so I was super excited about getting that job. But I also knew that I would never design an analog circuit in my life. And now it's 30 years later, and I'm designing circuits that integrate with analog electronics, as well as doing some analog electronics through that. So that was really cool. I forgot where I was going with that. So I've got some non-traditional. I'm not a designer by training, but I think in my heart I am a designer first. I think when I grew up in the 80s, it was sort of, the only thing I can reference as a designer in those days was like Chitty Chitty Bang Bang. And notice the guy's name. I figured this out just in the last 15 years or so. The guy's name is Caraticus Potts. So it's Crackpot. That's his name, is Crackpot. I don't know how many people get that, but it blew my mind. I
didn't get that.
Just the notion that they're calling this guy a crackpot because he's this, crazy designer. He has to go out in that garage every day and build vacuum cleaners and hair cutting machines and cars that fly, and that to me was who I was growing up as a kid. It's like, I want to do that. But, how do you get a job being Caraticus Potts, right? It's like, I never put two and two together. And then my dad bought me this 1001 or 101 electronic kit, and I couldn't figure out how a transistor worked because it had 3 wires coming out of it. And he couldn't tell me either. He was an electrician, but he could wire houses and stuff. So that's what made me become an electrical engineer, is just to figure out what the 3rd wire was on a transistor. But in my heart of hearts, I think I've always been a designer, but didn't go to design school or anything like that. So that's a super long story with lots of side things to say that this design, the tool I use for designing is PowerPoint, which will completely blow people away, right? It's actually a quite powerful drawing tool, and there's a lot of drawing things in there that are hidden when you use PowerPoint day to day. And if you go into it and configure it, you find that there's Boolean operations for the 2D objects and all that. So anyway, that's
to add a side note on that.
Yeah.
I'm looking for a way now, like part of the vision of the Academy is to bring musicians who have some sense of a visual design or whatever. Like they don't really, they're not technical with Photoshop or Illustrator or anything like that.
It's really hard to, it's hard to learn that stuff.
To get them in. And I was really considering working with PowerPoint or Google Slides for these lessons for a particular group of people, because I mean, you can actually do a lot of stuff there.
Yeah.
Well, but go ahead.
You build a palette. Like you'll see, this is like literally. I went through. We talked about putting some sketches together. This is the first slide one. Mm-hmm. At Intel, we thought that's how we think. That's how we communicate with PowerPoint, right? So after 25 years of that, it's like boop, PowerPoint. Just take notes in there and throw stuff together, right? So I did this graphic, and it's. So the idea was for the Noodler to have multiple, be able to control multiple synthesizers. So down the right side, there's the arpeggiator, and down the left side, there's a pad and then the bass. So you can kind of see those knobs. And then I had this idea that these arrows on the screen would point to which of these labels you were turning when you turn the knob. So you press the encoder, and it would toggle those arrows up and down, and that would be which thing you were turning. So it's trying to overload the physical knobs without menu diving. That was kind of the idea. Let's go to the next one. I just wanted to see we had crazy background ideas, but it's basically the same thing. But you notice now the screen got rotated. So I was thinking about, user interface design in that screen area. Kind of moved to this. I start taking notes thinking about at the same time as I'm designing, I'm also thinking, well, how many GPIO ports do I have on my, Arduino that I can actually hook knobs up to? So these were you were asking about how do you limit design creep? Well, one of the ways of doing that is sort of choosing what your platform is going to be, and the platform can only support so many buttons and so many knobs. And literally at the time, I didn't know about shift registers. I didn't know about, a lot of things. I was literally just learning all this stuff. Even though, like I said, I got a EE degree, it's all math based and it has nothing to do with digital manipulation of buttons and knobs. So, as I was learning, but that's, you notice it says Teensy LC there on the bottom. That was our target platform.
Oh yeah, I see.
Yeah. Let's see. So how do you prototype, right? So I wanted the faceplate to be black with white ink, but how do you print white ink? How do you print with white ink? No printers have white ink, and so without wasting, toner cartridges full of ink to print everything black except where you want the white, we literally printed these out at Costco. This is a photograph printed at Costco, and then I cut the holes out with an X-Acto knife. The round holes, I actually used little pipes I bought at the hobby store. I put it in my drill, and I used a file, and I sharpened the edge of the pipe so I can use it as a punch to punch the round holes out for the encoders.
Cool.
Yeah, talk about wasting a lot of time, right? Going down like all these side. But, we didn't know what we were doing. We didn't know how to prototype, so we just was making it up on the fly. So this was a photograph that I think I laminated. Yeah. Notice there were square buttons at the time, and then I think this was also hand cut. Yeah, I think so.
This looks really cool.
Yeah, this was just some ideas about what the UI could look like. And then Daryl is a big fan of Octopus, so I made an Octopus version for him one day. But you can see I put this one on because you can see, I don't know if you could see, but like the third knob down, it's literally crossed out with pen, and I'm writing the new names of things. And as these evolve, those names get changed.
Is this something you are placing on your controller, or?
Yeah, absolutely. Let me show you. So,
You'll have to stop the screen share.
oh, okay, sure. So what we did was we took acrylic, and we found a friend with a glow forge, and he would cut these acrylic pieces for us that had all the holes in the right places, so we could bolt the PCB onto the acrylic. And the way they were held on is through the encoders. The 8 encoders have, and then I would take these pieces of paper that I'd print and cut and put it underneath the acrylic.
Right.
And so this is an interesting one, because you could see that there's 3 buttons here, and there's no buttons here, right? And so this is a transition. We went from the original PCB with a Teensy LC plugged into the back here. We're using a Teensy 3.2 on this one. So that Teensy plugged into the socket in the back, and this was just basically what they call it as a shield. But as we evolved what the shield layout was, from a design standpoint, I actually just printed this out to show what it would physically look like when we got the new board. Let's see, it would be this board. With the 4 buttons on the bottom, so two on this side and 2 on this side. So this is the next one, and on this board, the Teensy is right here.
Right.
Instead of using it as a shield, we laid out the design, so the Teensy chips and everything was on one board, and it's no longer a shield. This is the Teensy, essentially.
Right. How do you do that?
Well, Daryl does all the layout, and this board right here is Daryl's first board he's ever laid out in his life, right? So while I'm in here trying to figure out how to program, he's in there trying to figure out how to use
Eagle or KiCad or
it's pads. Actually, we ended up using pads.
Okay.
And well, the Teensy guy, Paul at PJRC has. Or there's some others, I can't remember. Daryl decided not to be on a call, but there's sort of an evolution of the layout for this is freely available, and so you can look at the schematic and figure out how to lay out a Teensy on your own board. Right. And they're fully supportive of that. It's not like that's going against them, or he's like, oh, absolutely. In fact, we had a release party when we came out, and it turns out that Paul lives in Portland. That's where Teensy is. So he came to our release party, cool. And so he's totally for people using his stuff on their own boards.
That's so cool. But then, so the whole thing is still based on Teensy.
Oh yeah, the shipping product is based on Teensy. Absolutely.
Why did you choose Teensy for that?
Well, the honest answer is kind of didn't know what we were doing. Right. Okay. So Teensy is programmable in the Arduino environment, and like I say, I'm a double E, and I loved programming, but I'm not a programmer by trade. So I knew how to program in C a little bit, and I popped open the Arduino environment, and it's like, wow, I could make this little green microcontroller thing talk to some knobs and spit out MIDI. And it was like that day that we watched that Notes and Volts video and learned how to make that happen sort of was it. I mean, this is like grassroots through and through. Yeah. In fact, this is slightly embarrassing, but you
again have this noise.
Oh, I might have
a bit of a different noise.
Okay. It might've been my arm rubbing.
Okay. Yeah.
Is it okay now?
It's okay. Yeah.
Okay.
The Noodler you were saying?
Yeah, the Noodler is coded in the Arduino environment, and there's tens of thousands of lines of code. And I can say that I nearly lost my mind programming this product. It took over a year, and there's multiple files, but it turns out that the way the Arduino environment teaches you how to code is not the right way to code. It's not C. It's C syntax, but not the file layout is not the normal C file layout. So it taught me some really bad habits. And then a good friend of mine who I worked with at Intel, in fact, there's a lot of that. We've got like 4 or 5 people who like satellites around our company have been helpers in a huge way. Like I said, Daryl figured out how to design the circuit boards. We have a friend also named Paul, who actually designs organs and synthesizers for a living. And friend of a friend kind of thing. He got in orbit with our company, and he just loves what we do. It's like, we call it the Tom Sawyer effect, right? We're down in a basement trying to make these synthesizers, and people who have real knowledge about do this stuff every day, but they can't leave their jobs because of families and responsibilities, love to come and help us because, and it's part of this extended family. Although Daryl and I are the two full-timers, we've got a guy, a real industrial designer named Nick Oakley, helps us on the user interface design. That's how I got from that, what I would call a medium to horrible design, that the last thing I showed you, to the design that's got this sort of look and feel to it with those graphics. And we'll get cut back to that. But Paul has helped Daryl on, like, okay, so we cobbled together the circuit on a breadboard and it worked. But what happens if somebody plugs the wrong jack into that hole, or puts 12 volts instead of 5 volts? Or we had no idea how to do any of that. And Paul came in and taught Daryl all these ways of doing protection for circuits and how to keep them from getting shocked and overloaded and wrong polarities and all that stuff.
A side note on that. Yeah. This experience that you had there is something that I think that a lot of people are really missing, because they might not really have this network or friends that can help them with that. And the fact that you can actually ask on the internet is amazing. And now we started this Discord community, and the whole idea there is that you can just like drop a question about Tinsy, and there are like a bunch of people who are working, like, I mean, now you are one of these people who are like, who know Tinsy really well. So it's really cool that you have this hub of professionals and students and enthusiasts who can like work together to figure these things out, because sometimes you just don't really know in your neighborhood or in your network someone to help with that.
Yeah, and I would say to people who are starting, go watch Dave's Notes and Volts thing. It's great.
Yeah, it's a cool channel.
But also, if you're going to get online and ask questions, just be prepared to have thick skin, because there's some real buttholes out there. I'm just going to say it, that you ask a question, and it's always good to approach it with hat in hand, right? It's always great to say, hey, I'm a noob. I don't know what I'm doing. This is what I'm trying to do. Can somebody help me? And you'll have 3 people, depends on which website. The PJRC forums are pretty good. You'll have a couple people that'll say, hey, you're a total idiot. What are you doing? You're not supposed to do it that way. Just don't worry about those guys. Just let that, people have their own problems, right?
Yeah, exactly.
But then there's also the other 2 guys that'll say, yeah, hey, I tried it this way. And, what sucks is those guys that are real asses, sometimes they're also really smart. So if they're willing to give you some advice, don't not take the advice because of spite, right? Just let it roll off, because that's just how they live. That's their world, not your world.
Yeah.
And there's a lot of good information out there. And then there's people that'll be helpful and kind and supportive, and those are the great people. But people come in all shapes and sizes, and
that's true.
Yeah.
Yeah, but you were talking about something.
I don't know. We were talking about, I guess, user interface design, right? We were going through.
Yeah, you were talking about your friend that helped out with designing the interface, the product.
Yeah. So if you want, I could pop back up to
go ahead.
Well, let me see. More show and tell first, I guess. So maybe things won't fall off.
Oh, look at this.
This is the Noodler. This is the first prototype. There's the MIDI jacks and the screen, all the switches and knobs. This is it. We never took it apart. And Daryl still comes back here once in a while, and we'll use this to test things once in a while. If something's broken, we can. It's still functional. It's an old firmware. The firmware won't run on it anymore. But but this is it. All bundled together with the wire ties, and There's the teensy.
Very cool. Yeah,
Yeah.
I'm definitely going to use the picture of this for the website.
Yeah.
This looks super nice. So back then, when you had
Yeah.
this, prototype, you still had the idea of that interface. This was just.
Oh yeah.
Yeah.
The reason why that doesn't look like a noodler is because physically you can't
Yeah.
put the knobs where you
Yeah.
want them, which was the first frustration. You did ask about Kickstarter. That's a great point. So, we're just two guys sitting at a kitchen table at this point. And, we did move down to Daryl's basement, which is where we're still at 4 years later. And thanks to Daryl's wife for being so kind to let us park here. There's a back door, so I come around the side gate and
Cool.
and I never go upstairs because I want to keep the house separate from the office for them. What was I going to say? So we did notice that there's a substantial number of Kickstarter projects that get funded and never ship, right? Not just electronics, but there was the famous cooler with a refrigerator and a blender built into it or something like that. So we thing that I love about working with Daryl and why he's probably one of my best friends is because we both have, similar outlooks on life. And one of those is, you don't screw people over. Both of us being very technical, we felt like we wouldn't want to do a Kickstarter unless we had line of sight to actually deliver something. Meaning, clearly we couldn't deliver that breadboard, right? So we did not. We had the first. This is not the first board, but we had our first board made and in hand, and the firmware running on that board before we did our first Kickstarter, because we wanted to. That was for us what we called line of sight, meaning we could put this in our first prototypes were literally the like I was talking about the acrylic faceplate, and this box right here is a box we bought at Target, and it's a kitchen. It's for holding your spoons.
Yeah.
And so we literally drilled some holes in the side, and the motherboard, the board that you just saw, is sitting on this acrylic, and then we just screwed the acrylic into the side of the box. So worst case, we could have delivered something like this. It would have been kind of a disaster, but we wanted to, in our mind, feel like we were not selling snake oil, right? That there was something real there.
Yeah.
Yeah. That was the notion of the Kickstarter, is that we wanted to know that we were past some level of competence to deliver a product.
Right. Yeah. Let's maybe go back to the
Sure.
interface to have a look there, and then I'd love to ask you about why do you even choose to work with Kickstarter, and how does it work on that end? But let's talk about interface design first.
So let's see. So are you seeing it now?
Yeah. So actually, why are there so many? They look pretty similar. Why do you need to print out and cut out all these interfaces?
So I made reference to my Lego hobby, which I've got some little Lego fidgets here. I'm a builder and a tinkerer, and I was relegated to writing software. And I just needed to sort of tinker and build. We eventually got this thing called a Cricut, which is a paper cutter that you put the paper down. You can print so what's cool about it is you can print something on a printer, and it'll create the outline, registration lines. And then the Cricut can sense those registration lines and cut with a little razor blade. And so we bought a Cricut for a few $100, it was exciting to actually be able to print a user interface and have the cutter cut it out so it actually fit the holes, and I didn't have to cut them by hand. And I just, it was an exploration in user interface design, from a visual standpoint, not from a physical standpoint, right? So we wanted it to look good as well. So we got paper at the craft store that had all this, this chart, this has got some weird texturing to it. It's all just printed on the paper. So we went and bought a bunch of all the paper that didn't have flowers and hearts on them at the store we bought. Anything that looked semi-masculine we bought. And I just kept printing stuff. I don't know. I couldn't stop myself. It was just a physical thing. I needed to physically touch something once in a while, and that's probably why. But there was also the iterations. Like for instance, this one, I don't know if you could see the 3 holes punched out here on this side. And then these 2 holes are not punched out, right? That was when we transitioned from what we call the 3-button to the 4-button board. And we literally didn't know what kind of that would look like. So that's why I printed this out, is so that we would have the 4-button user interface on a 3-button board. It was kind of a weird hybrid that we were transitioning through. And then this interface has the 4 buttons proper. And you can see the holes are cut a lot better. This is a cricket cut. And then this is, so this was given to us from Nick Oakley, who was our industrial engineer, who is a masterful. I mean, if you look at this, it's like, compared to my little, if you go back a few, like this, I had these little lines, and it's okay. But, when we sent this to Nick and he came over and looked at what we were doing and said, can you just pretty up our user interface? And then we got this back. It was like, holy crap, that looks like somebody intended to do that. It was like we were blown away. And so we just immediately went with it, because he's an award-winning, world-renowned designer. And I was like, I'm not going to argue with that guy, right? Yeah. He's literally beer money. It was, he's not taking money, right? It's like he comes over, we take him to lunch, and whatever, and then he comes, and then and he's been working with us for 4 years. That's awesome. So it's really great. This is now on like a blue background, and then there's a device. That's
fantastic.
So it went from this. I know we're a little postage here, but it went from this little plasticky thing to a real device.
Right.
Let's see it. So here's literally the first drawing to the device. It didn't. I was surprised how similar, right, in look and feel. The notion of a circle, the buttons are laid out. It's not the circle of fifths, but the circle of fifths have this circular thing, and that spoke to me, to thinking that it's for musicians to use this, it would feel maybe familiar. So that's where that whole circle idea came up.
Yeah. And I would say it's also very inviting, and it's like you kind of understand what you're supposed to press. There is a clear hierarchy of the controls. You understand what's most important. And I wanted to talk a bit about the interface from like the screen-based interface.
Okay.
Because I feel one of the biggest challenges that people are facing is how do you create a clear, intuitive, screen-based interaction? Because it always feels like menu diving. As soon as you start adding features, then it becomes harder and harder to do that. And what I noticed with your controls, first of all, is that you actually had 8 knobs on the sides, and this reminded me right away of my Digitone and Digitact from Electron, which I also feel like it's always this connection between 8 controls to the screen, and they're related to the space on the screen, which makes it super intuitive to work with, at least for the basic functionality.
Okay.
And I just wanted to ask you how did this come about? How did you realize this?
It was just intuition,
right?
Honest.
Because you did have the 8 controls from the beginning. Like the first sketch, you actually had these 8 controls.
Yeah. I think it was literally, we figured out how to get 8 encoders to run on. We used muxes instead of shift registers. Well, you can't really use anyway. We used muxes for the encoders. And
what are muxes?
It's like a shift register in a way. You use 3 lines in binary to give you 8 combinations, and so you send an address to the mux, and you have 8 inputs into the mux, so you can connect 8 devices to it, and then 1 output. And the three address lines tell the device which of the 8 inputs to have show up on the output.
Okay.
It's a bit like a shift register.
Yeah.
Kind of.
Yeah.
And so what we did was encoders typically have 2 outputs. And I want to get into the nastiness of how encoders work, but they toggle up and down basically as you rotate them. There's two concentric wheels inside the thing that you don't touch or anything like that. But as you sweep that knob around, God, there's some technical term for this. I can't remember. I'm having the senior thing again, but anyway, they will trigger basically what's called a gray code, 2-bit gray code, and that means every time you sweep across that knob, it'll go high low on both of these.
Okay. And
that's how you count whether you're turning it clockwise or counterclockwise, and that's really all you get on an encoder, is that you moved it either clockwise or counterclockwise. It's then up to the program to do something with that. So if I've got a value like volume, if I turn to the right, every tick I get coming from the encoder, I will increase the volume by 1. If it's counterclockwise or anti-clockwise, I might decrease it by 1. And that's kind of how the math works there. But anyway, in order to have this microcontroller read all of these encoders, which required 16 inputs because there's 2 for each, we use these things called muxes. And I think the 8 buttons, I think, just came out of the fact that each mux had 8 inputs. So 2 muxes would give me 16. Instead of choosing 7, I had the opportunity to have 8. So I used 8 without having to have 2 more muxes, which would have given me, 4 more. Yeah. Anyway, so it just turns out that the electronics kind of drove how many knobs. The number of buttons in the circle was driven by the fact that there's 7 chord degrees in a scale, most scales. But we were talking about the user interface design of the screen. And I just had this notion of, I didn't want a menu dive, but I wanted to have those knobs multifunctional. And so this is a bad screenshot because this is showing a different, well, it's actually not a bad one because it speaks to what you were just talking about. For instance, if you look at where there's the number 9 in the rhythm, it says rhythm load. Yeah,
maybe you can Control plus to zoom in. Not sure if it works on window.
Let's see. Control plus.
Yes.
Yeah. Right. I don't know if I can. Oh, I can. Gotcha. There we go. So right here, this 9, this box up here is visually in the upper left-hand corner, which is this upper left-hand knob. This box with the 27 is the upper right-hand corner, which is this knob. And then you'll notice I created 8 boxes around this. So as you go around these boxes, these 4 boxes on the right side, they correspond to the 4 knobs. And these 4 boxes on the left side correspond to the left knobs. So I throughout the whole use of this thing, I purposefully designed the screen so that the physical locations would correspond to the knobs.
Yeah.
And even if it was confusing, it's like, well, which one is it? Oh, it's you just remember, oh, it's that one, right? Because it's the second box down. So even in a situation like this where it's not, the boxes aren't symmetrically sized, their physical location on the screen dictate the knob to use.
Yeah, position can be a very good signifier for stuff like this, especially if when this is just a good example.
Yeah. You know what? Let me go off reservation here, and I'm going to pop this open. Let's see. Let's just go into my. This is looking. Can you see this? This is looking into Steve's brain. It's kind of scary, but like here, if you look at you'll notice that there's 4 arrows, and again, these arrows, when you press the encoder, that arrow will flip vertical, up or down, and that will tell you which of the. And then also had this notion one night. Oh, it's like the 4 a.m. 4 a.m. is a good time for me design wise. I don't know where my video is, but it's kind of obscuring. Maybe it's not on yours, but this knob down here's got 3 labels.
I'm not seeing now what you're seeing. I just saw the arrows. I'm still seeing that mustard color interface. Yeah, now you're zoomed out.
Okay, so it says tempo, key, and mode. So on this bottom left encoder.
Yeah, and then you have the arrow up that indicates tempo, down
right.
mode, and then left is
exactly. Key. Then when it's pointed sideways, I realize, hey, I can get a 3rd mode on this. So, so now that a couple of them now have three modes where it's 1, 2, and 3. Yeah. Mm-hmm. So that you can see that this interface has got this giant number 58 in the middle of it. Because the original idea was, as you turn these knobs, I was just going to give you values. This is kind of speaks to your feature creep a little bit. Here's an example of what these things, what the areas mean. Like, but then I realized that this number is it says encoder, a current encoder value. What the hell does that mean? I've got 16 or more things that I'm turning, and I got to remember what 58 means on the 3rd knob. That's never going to work. So one of the things of feature creep, it's not, I don't have any examples here, was that in the current screen, the center of the screen became knob context sensitive, and the outside of the screen stayed the same. And I think that might also be one of the things that helps. You know what? Here, let me give you. Let's see if we can do this. I'm going to stop sharing here, and I'm going to flop over to the other camera really quick because I've got my noodler here.
Yeah, I'm not sure if I'm gonna. It's unfocused. Oh yeah, that's not too bad.
Is that okay?
Yeah.
So the middle of the screen here where the box is, that's context sensitive. So if I turn, it's in motif mode right now. So all those things inside that box are for these knobs. Mm-hmm. If I rotate this knob, for instance, the context changes.
Yeah.
And now that's for the drone, which is this knob. And if I come up here to the pad and change it, now I've got all this stuff for pad. So although, there's some changes, still the rest of the screen stays familiar, right? If the whole screen changed for everything, I think it would be very confusing. And here's an example of the knob. So if this knob down here has got 3 labels. So I'll twist it to get into that context. And if I push the button, you'll see it goes.
Yeah, that's to the right and to the bottom. Yeah.
Yeah. So that's how I choose what the function is of the button. And then all the information about motifs, because I'm on a motif button or knob, is in the middle. But the rest of it is, this always tells me what the status is of the 4 parts, the 2 motifs, the pad and the drone. This tells me what I'm twisting, as we talked about. I got the BPM there. And then the top part tells me things like, those are the 3 parts. So if I change a position, you'll see that it moves. So that's a relative position of where my motifs are being played. If I twist the type, you'll see it's an up, down, it ping pongs. So I'm trying to give some visual indicators. And then all these things are modulatable. So if I was modulating the position, this thing actually animates and moves back and forth across the screen. So there's always this visual representation of what's going on.
Yeah. Yeah, visual feedback is super important.
Yeah. When I got into the menus, this is really strongly talks to this box is this knob. Oops.
Yeah.
These 8 boxes correspond to the knob. So I don't have to dive into any of these menus. As I change these knobs, the values just change.
Yeah.
Right away. Yeah. All right. Sorry about that. Do you have any more questions before I pop back to my?
No, let's get back to the regular camera.
Sure.
And sure. I would love to talk about the moving from having a prototype to actually realizing a product.
Oh yeah.
What does it mean to decide, okay, we are going to go with Kickstarter? And what does it mean to like, what does it take to actually make something that, okay, this is now for me. This was awesome. I created something for myself. This was the goal.
Right.
Now I want
How do
to,
we,
bring it to the world.
Yeah. Great question. Well, lots of questions. You have to ask yourself a lot of questions at that point. Like, firstly, when we made our very first prototype, which was on some pref boards in a box, and we squished it all down in there with that, and it literally wasn't a PCB at that point. It was a handmade PCB essentially. Where to start? Okay, first thing, I'll just start with what comes to mind first. Firstly, we thought about Kickstarter a lot and kind of thought, what does Kickstarter actually do for you? And we realized that, well, it does, on the surface, it does exactly what it says. It provides money to build something that you might not have the capital for. So Daryl and I, we're not rich or anything like that, but, we just retired from Intel after 25, 30, we could have kicked in the money to make the first build of these things. And so we weren't really desperate for the money. But what we quickly realized was, hey, if we can't pre-sell X number of these devices, if people aren't going to give us their money for them, maybe it's not the right thing, right? And so in a way, Kickstarter is the ultimate in marketing acceptance. Mm-hmm. In other words, if you can't fund, you may not have the right thing.
Yeah.
And so really what was most important to us was funding to see if enough people cared to buy it. And let me tell you, it's a bit like going way back to what we talked about asking the right question, like, do you have batteries in your device that are mm-hmm. charged? It's sort of the same kind of question. It's like you could go to, we live in Portland and it's quite a synth-rich city. So there are synth jams all the time, and we could actually go, we do, but you could go somewhere with a prototype and ask people, hey, would you buy this? And they'd say, oh yeah, that's great. We'd love to buy it. Well, that's quite different than if they give you $200 or whatever we charged originally for the noodle, or maybe it's $250 or something. We changed over time with some, but unless people literally give you their money, you don't really know if they would buy it or not. Them telling you they'll buy it might just because they want to be nice and they think it's the right thing to do and that's fine, right? Again, people come in all shapes and sizes, but when the rubber hits the road, it's people are either going to give you their money or they're not.
Yeah.
And Kickstarter is that place. They either did or they didn't. And so that's why we decided to use Kickstarter more than getting the money. It was more important for us to know, are we wasting our time, or did we actually build something that somebody wants? Mm-hmm. And again, they voted with their dollars, and that's how we knew it was something to do.
And at the time, you actually have this prototype that you feel comfortable to even just ship this, but then you do more research into how do I manufacture this?
Yeah, we because we had a PCB made. At that point, it wasn't just a prototype that we built by hand. Mm-hmm. We had the PCB made. And we figured, how hard could it be to make a box, right? I mean, that's not a technical line of sight item, right? That's something that we knew we could get done. Getting a PCB to work, we didn't know we could get done, and having the software be able to download to that thing and work and makes noise. So once we got past having the PCB and software working on it to the point where the noodler felt like it was actually noodling, that's when we decided to do the Kickstarter.
Right.
Yeah. Then synonymous with that, it turned out that the NobCon in Chicago, which is a US-based show, was that month, and we rented a table and we flew to Chicago with a couple prototypes. We hung a sign up on the table. We bought one of these vinyl banners that we could hang on the sign, and we made up some T-shirts because my friend has a T-shirt press, so we got some iron-ons and made a T-shirt. And we went to NobCon and we showed it to people, and that you made a comment earlier, maybe it was before we started recording, about non-musicians can use this because they don't know music theory and it just happens for them. But even if you do know music theory, it's still helpful. And we learned that at KnobCon because, we anticipated that it would be for non-musicians, right? It's like, you already know how to play this stuff on a keyboard. Why would you buy this box? And we literally said that to this guy, and he goes, no, I'm a keyboard player, and look, I only have 2 hands, and your box plays 4 parts. It's like, I want this thing because I know enough about music theory that by pressing these buttons, I could change the chord, and I could play on the keyboard at the same time. And then, of course, that triggered some more design things, like you can plug a keyboard into the Noodler, and the Noodler will filter the notes to match what key you're in. So you don't even know how to, you could like pretend to play a lead on a synth and it will come through the Noodler and sound mostly right.
Awful.
And so we learned a lot from that show. But again, we sort of wanted to see, we were in the middle of the Kickstarter and hadn't funded yet. And we were at KnobCon and people were coming by and telling us, that they thought it was a really great thing. People would just pull up a chair and we had to actually tell them to move because they would be there for 30 minutes.
That's
they
awesome.
throw on their headphones. We brought a couple of desktop synths and yeah. And then we didn't even know, but we had some people that were pretty heavyweights in the industry who we didn't even know who they were. And then figured it out later. Yeah. Of course, it was fun because we also got to hang out with Tom Oberheim that night.
Oh, really?
Yeah. So that was
fantastic.
a little icing on the cake. Yeah.
That's awesome.
Yeah.
So how do you price a product?
Mm-hmm. Well, we knew how much it was going to cost us to make.
Mm-hmm.
And that drove a lot of the design decisions, right? Like you can't have, we decided to have a screen, but it was like, you can't have a giant screen. We all come from the PC world, right? So it'd be great to have like
a 4K.
like an iPad with knobs, right? Maybe. I'm just saying that, right? Because there's reasons why you wouldn't want an iPad with knobs. But so we tried to keep the price down, and it's a great topic because this board is very simple to make. And we, what is it called? Design for manufacturing, right? Mm-hmm. So in addition to designing a user interface that's welcoming and familiar, we also design for manufacturing so that this one PCB with these 4 knobs just get pushed up against the faceplate, gets screwed on, the faceplate drops into the box, and it's done. You can literally make once the PCB is done and you have the box, you could assemble one of these. I can't remember what my record time was, but like 8 minutes or 12 minutes or something like that. So it was really a quick assembly. So we knew kind of what the prices were because we designed it to be manufactured quickly without a lot of custom parts. Everything was off the shelf. The screen's held on by some sticky tape. The only custom part we had to make, well, the enclosure was custom, and then we needed to make the screen cover, which was the trickiest part of this for us the first time around, which is you have to, machine off the edge of the screen so it could fit up into the faceplate metal, only as thick as the metal is. And then the rest of it sits proud so it won't pop through. Right. But then when you press down on it, we didn't want it to hurt the screen. So we had to figure that out. But aside from that, it was, okay. So then how do you, so you're limited, you need to know what your costs are, and you want to keep those low by designing to make it easily assembled, few to no custom parts. And then, well, we just looked out and did a lot of sort of what we'd call competitive price analysis. We just looked out in the world of synthesizers and controllers and just said, well, where's the sweet spot? Where's there's several, like, if you look at things, there's a very small $100 category, a very large $300 category, a smaller $600 category, and then an even larger, plus 1,000, 1,000 plus category, right? So if you're going to buy a Dave Smith Instruments synthesizer or a Moog synthesizer, you're in the plus 1,000, right?
Yeah,
that's not.
It's also a bit of
were.
a different comparison because this is a controller rather than.
Oh, sure, right.
Have,
yeah. And then, but just thinking about it, well, it's a good point that you make, but also if you think about it just from an economic standpoint, people have X number of dollars that they're willing to spend. And it feels like there's categories of how much they're willing to spend and what they expect back for that. So the under $100 is easy because the wife or girlfriend might not know about it. The $300 is maybe you have to, let somebody know, but you could, or you could justify putting it on a credit card because it's $300. You could probably pay it off pretty quick. You're not giving up a month's rent, right? So we kind of looked at it more on that level in terms of these price categories.
Right.
And we knew we needed to be around the $300 price point. That was sort of the sweet spot. There's a lot of controllers out there that are, I'm sorry. Yeah, let me finish that thought. There's a lot of controllers out there that cost $1,000. And I shouldn't say a lot. There are controllers.
No, yeah, but the Linstrument, for instance, is one of these.
Sure. The Seek, the large. I'd love to have one of them, but they're $1,000, right?
Yeah.
Nominally, sometimes even more. So it's like we often wonder about what it means to be a boutique company versus a manufactured company. Is there value? Well, I'll tell you. So here's the story. So we had these made in China. Like you have to make these in China because we have electronic manufacturing in Portland because Intel is here, and then all the subsidiaries that support them. But they literally wanted, I can't remember, but it was on the order of $300 to $400 to make a board. And it's like $300 to $400. The product is less than that. How could you possibly make that board, right? So the American costs of manufacturing are just literally insane. I mean, unless you're making like a $5,000 medical device or whatever, which is offset by insurance companies. There's all these problems with manufacturing in the first world now, right? So we had to go.
This is €300 just for the board without the parts, without assembly, without anything.
Just for this assembled.
This assembled, okay.
Yep.
Yeah.
So this complete with the parts and everything, right? I don't really. It's much less than that. Let's just say. In China.
Yeah.
Like a quarter of that, right? And so we had the enclosures made at a machine shop locally. Total disaster, by the way. These guys make landing gear for Boeing. So we figured, they're a subsidiary, right? We figured they could make a simple box and anodize it. It's crazy. It's a whole other discussion about manufacturing, right? About how hard it actually is to get things manufactured. But anyway, we got the boards manufactured at one of these, PCB way, or I think it was PCB way, and enclosures manufactured here in Portland. And then we ordered the knobs and the button caps and things like that from China. And we're sitting at this table behind me, super excited, right? We're building our noodler. We're building our baby, right? Oh my God, it was like the best day, the first day manufacturing went online, right? So we work all day, kind of get the bugs out of the process of building it. And there's like 15 of them or 20 of them sitting over there. And it's like, okay, day 2, 20 more. Day 3, 20 more. By day 6 or 7, I'm sitting there going, hey, Daryl, because we're sitting across from each other, at our own little workstations. It's like every day that we're sitting here putting these boxes together is one day that we're not spending making our next box. And this is literally a $20 an hour job. And we should be doing our $150 an hour job. And economically, this is just not making sense because it was going to take us 2 months or so at the rate we were going to put all these things together. It was like, this is insane. We just can't do this. So we hired a young guy who was really nice. He came in and we paid him we paid them per part. Every one that you assemble, you get X number of dollars. And we decided to incur that cost because we just needed to get to our day jobs. It was super fun being that boutique manufacturer, but it was just not a good use of our time.
I think it's still a boutique manufacturer.
What's that?
If there's just one person you're paying for, you're still a boutique manufacturer.
No question. But our next 1,000 units that we got made, we have now, they're made in China.
Yeah.
100%. We don't see anything. We don't even see the products. We ship directly out of Hong Kong, and we have a manufacturer in China who is this young American guy, right? And we knew that this. I apologize. I'm not trying to demean anybody, but it's there's language barriers and there's just quality assurance problems. So we wanted somebody that was sort of feet on the street in China that we could look in the eye and know that there was no language problems. Mm-hmm. And that, here's the quality, here's the this, here's the that. I jumped on a plane and flew to China and stayed there for a week and got them up and running in terms of building it. So, it's a small shop. It's 5 guys around a table instead of one. But they've got several customers, on the order of tens of customers, and they're doing these small runs for them. But the economics were just so much better to just have those guys, and they're great young men that we have weekly calls with them, and that's how we do it, And I don't know from where there comes this glow of, I hand build these. I want to put the Noodler in as many people's hands as possible, not because I'm greedy and I'm trying to make a lot of money. We are not making a lot of money. I mean, both of us thought maybe this would be great company to have. And we're getting to the point where, again, that line of sight thing, where maybe if the MRCC starts selling, and now that we're shipping it in large numbers, that we might recover. But we worked for free for the first 2 years, and we're literally paying ourselves far less than you would make as a waiter for a fast food restaurant right now. But the number of units that we want to sell, it's like, it took me 2 years to write this firmware for the Noodler. I don't want to make 100 of them to make it just worth my time, not money wise, but just energy wise. And Steve's brain literally having a nervous breakdown writing this code. It's like, so, we thought maybe we would sell, if we could sell 3,000 to 5,000, that would be a good number. We'd feel good about that. But going back to the sitting at the table, putting them together by hand, if you scratch out the numbers of making 5,000 of them sitting at this table, no, it's just not, it just can't happen. You literally need to have them manufactured. Yeah. And then that's what we did.
Yeah, but it's also, this was not really your vision. It's not like you wanted to sit and solve. I can imagine that someone 20 would be like, oh, that will be fun. I can solder my own stuff. Like, yeah, okay. I've been there, done that. I want to use my brain much more than that. Like, it's. Yeah. Back then it made sense. Now it's not. So yeah, that I think is
I still sit and solder stuff, right?
Yeah.
Like this is literally, I just did this a couple weeks ago, right? So I don't mind doing this, a prototype like this, right?
Yeah, but that is a very different thing.
But that's a very different thing
yes.
than making 6,000 or whatever, 3,000 of the same exact thing.
Yeah. If you refer back to your Lego fascination, just imagine you just need to build one Lego box 5,000 times. That's
right. It's just exactly. It's not fun.
Yeah. But I mean, this is we've been talking for quite. I mean, this is probably the longest conversation I had, but I don't mind. This is really
I'm
interesting.
So sorry.
No, not at all. This is not a problem. I mean, I'm still. If I'm thinking about the way that I prototype heavily with everything I do. Courses that I work with students are always on iterations, and this thing that I did now, that I'm doing now, is basically, it started as like one post on Instagram, maybe 10. I challenged myself to just make 10 micro lessons on Instagram, and then it kind of like 300 followers, and like a lot of them are like manufacturers, and they really liked it. And then I did more and more and more. to the point that I felt like, okay, I should invest a bit more. I'm going to create some sort of a course. I'm going to interview people. And then I realized I have all this knowledge here. I should make a podcast out of it. And then I just decided I'm just going to release these podcasts, but then people really like them. So I decided to do a bit more. So now I'm kind of looking at the format of like maximum 1 hour and I'm like doubting it. Maybe it can actually be longer. I mean, at a certain point, all these podcasts should become audio available on Apple Music and Spotify, and then it's much easier to consume them.
Right.
So I don't mind making it longer if you don't mind.
Yeah, I don't mind.
Okay, cool. Then my next question would be, like when, so there was this point that you decided you're going to hire someone to build it for you. And then there was another point where you decided I'm going to move everything to China. How does this happen?
Well, boy, that was really frustrating. We were ready, we were almost ready to give up on the company because it's a great question. And I wish I had a better answer because this is a big hurdle and I don't know what the answer is. And if you can find that out from somebody else and like publish it, that would be great. Right. I'm hoping that, it would be great if there was like the www.whatever.com, findaguyincHina.com, right? But I don't know where that is, right? Again, it was all luck of the network. I had a good friend at Intel that we worked together many, many years ago. And I got in touch with him because he was the only marketing/business guy that I really liked. And I said, man, we should call this guy. His name is Ed. We should call Ed and see if he'd want to come work with us, be our CEO, right? That's sort of what our goal was. Mm-hmm. So he actually flew up to Portland and he sat around with us and he's into venture capital and stuff like that. And he's like, no, man, I can't work for your company in Daryl's basement, right? He's been a little more successful than that in the past, and which I didn't know because I hadn't talked to him for a long time. Mm. But what Ed did was got us in touch with, he has a network of people who are starting up startups. And so the young guy that his name is Gordon, who moved, he graduated from Yale, and he's just like, I want to get into manufacturing. So he learned Chinese in school.
Wow.
And moved to China. And it's like you got it. He's 27 years old. I mean, he's wise, like well beyond his years. It's like when I was 27, I was not getting on a plane to move to China to just start a company. But he did it. And so Ed put us in touch with Gordon, and the rest is history. I mean, that it was like, yeah, we could make that. At that point, we had already made the first batch of 600 units. So it was easy. Here are the Gerber files. Here's the files, the step files for the box. Mm-hmm. The CAD files for the enclosure. And we had everything, the manufacturing steps. So, we made videos and then I went over there and trained them up on how to do it. The MRCC, we're using Gordon as well, but that was a whole other evolution because no longer were we going to Target and Craft Warehouse looking for boxes to put the MRCC in. When I went to China, we had gone down to the electronics market, which completely blew my mind. And in fact, if it wasn't for COVID, I would probably be living part-time in China right now.
How come?
Well, like I said earlier, this sounds, frou-frou, but my soul is a designer. I am Karaticus Potts incarnate in 2021. And when I went to this electronics market, and it's not just electronics, there's these markets for everything. They just make shit in China. And it reminded me, my dad was a World War II vet. I'm like a really, really, really young a boomer. Mm-hmm. Like the last, actually, I don't even qualify, but I qualify because my dad was a World War II vet. That's kind of how I look at it, right? When I remember my stories of my dad and going into I grew up in New York and seeing these places where you'd go to the electrical warehouse and you go to this warehouse and stuff was manufactured, made, and warehoused in America. Mm. And you could go buy stuff to build things, right? Mm. There's no place to go in the United States that I know of to find
I get it.
An electronics market. right? Not even in any, if I had to travel to San Francisco or New York or Detroit, wherever, fine, I'll go there. But there just isn't a marketplace.
Yeah. Forget about it. Here where I live in Rotterdam, there is no electronics shop.
Yeah.
I have to order online, or I need to go
Yes.
to The Hague
Yep.
to the electronics shop, which is ridiculous. I was like, I should just start local workshops here and have a stock of like diodes.
Yeah.
So when someone gets stuck, they can just come and like buy them for like 10 cents.
Yeah.
It's really frustrating. I completely see your point.
Yeah. And I think we're in a really golden era right now. The internet has, for all the bad things that social media can, I love watching this guy, Lex Friedman. He's really great. And he was just talking the other night. He said, he was really, anyway, there's a lot of vectors in which social media can bring society, right? Mm-hmm. But clearly one of the vectors is mass education for free.
Absolutely.
And man, I think about college and how hard I struggled through college. And I go up and I go back and I try to, and I'm working on some projects that I need to understand some calculus, right? I'm taking calculus classes from this guy and I don't like it. So I go to this guy and I don't like it. And I go to this guy and I don't like it. Poof, the fourth guy, bam, for some reason, that guy speaks to me, or girl, I don't mean to be gendered, but that person speaks to me. And it's like, and then I just look and bam, there's like 20 math classes or 50 math classes that this person put online. And I just watch them all. It's like going to college and it's completely free. Yeah. And it's the teacher that I love. When you had that one teacher that you really loved, every teacher could be the teacher that you love now. And they'll even answer questions. You can even, just send them an email and say, hey man, I've been watching your stuff. I really love it. And it's like, hey, thanks for watching. It's like, wow, I even got to talk to that person. And so there's this education that's out there on every topic known to mankind just about. Yeah. So we're in this space where the Craticus Potts of the world can now rise, right? We can all start building stuff based on these things. So it's like right here, this is it, right? Mm-hmm. And it's relatively inexpensive. I mean, this board right here cost me like $20. So the education is available and the components are available. And the libraries, the whole idea of, so you got the internet with the education, you've got the idea of open source. So there's repositories of libraries for all these different electronics platforms. I guess what I'm trying to say is if you're watching this and you're not doing it, just dive in, man. The water is warm and shallow. It is. I mean, it's deep conceptually, but shallow in terms of being a welcoming place. And now is the time. My life has completely changed in the last 4 years because coming out of Intel after 25 years, I wasn't sure what I was going to do. I didn't really know what my own value was. And watching Dave's video on Notes and Volts just lifted me just to that little bit to give it a try. And wow, I'm shouting out to Dave so much because literally that man has changed my life. And I want him to I've told him that on emails, but I just want to say it publicly. I mean, I just think we're in a golden era of being able to do this stuff. And to that end, it is unfortunate that there are no electronic shops in every major city that I can go buy Arduino boards and all these components. And it's frustrating that, I can buy an encoder for like 50 cents online from China, and I got to wait 3 weeks to get it or whatever. Mm-hmm. But if I do find a place that sells it, they want like $15 for the encoder. It's like, come on, guys. This is our country in terms of, growing the inventors of your own land. It's like first world needs to re-engage in what we call third world activities now, because it's really, I don't know what I'm saying anymore, but it's.
Yeah, no, but I totally get you. It's like, I feel like one of the most important things that you get at college is that the fact that you actually have the facilitation, you have the workshops, if my students would not have, actually they did not have in the last semester because of COVID, we did not have access, or we had very limited access to 3D printing, CNC machines, metal and wood workshops, and they had to realize their ideas. Like they worked for a whole semester on prototypes and just wanted to fabricate them at the end to have something. And this is one of the biggest values of the Academy, to give this space for people. And just imagine that you would have this out. I mean, just like the internet just opened up everything and the knowledge is out there, just imagine that you would have these workshops everywhere. So people could just like pay a small fee. I learn everything online and I can just go to these workshops and build there, and I can make my own stuff. So I don't need to want to live in China, like outside of my country, because I want to be creative.
Right. Exactly.
And in a sense, you can do it if you have the, I mean, in the Netherlands, apartments and houses are actually really, really small. I'm in like a 2.5 meter on 2 meter room. And that is like my shed. But but in the States, I know that you guys have actually like larger spaces, so you can actually buy your own fabrication tools to work on things, and that can replace that in that sense. But it's not a very social experience as well. And there is something to go to the shop, to go to a workshop, work with some people, and I think that's really missing.
Yeah, that's wonderful. That is, I think you're nailing it. That's a great. Those should pop up everywhere. Yeah.
I just had a conversation actually with David Ranger. He's in London. He's making these really wild guitar effects. Super fascinating conversation. We should definitely listen to it. And he was talking about just building fabricating the aluminum enclosures with a local workshop. And I was like, that's really cool. And then I went to a local workshop here in Rotterdam. So apparently for aluminum and metal, there is a workshop I could work with.
Oh, okay.
Yeah. So, it's nice. But let's wrap things up. So the idea is that as soon as you have something like 600, you are able to move it offshores to China to produce it for you. Would you do this earlier if you could? Like, would it be wiser to do it earlier?
So, one of the things that happened with the Kickstarter is we funded at 120% or whatever, just enough to get us over the threshold. And I remember being really jealous of seeing other people like, holy smokes, those guys got $1 million, right? It's like,
and they have a marketing budget for these campaigns, by the way.
A lot of it is skewed. And we were literally making videos down here in the basement with a camcorder. I mean, it was like, and you're looking at this other stuff. It's like, wow, what's going on there? And I still don't fully understand it, but something's going on. It's not two guys in the basement. But I won't talk for Daryl, but I was a little jealous that these people were making all this money. And then we got down to, once the money came in and we owed, several hundred noodlers to people, that's a lot of pressure to have on your shoulder if you're a person with value, right? I mean, there are people who don't care if they deliver or not, but we really did. And it was a lot of pressure. And I started thinking to myself, man, I am really glad that we did not sell 5,000 of these things and have like $1 million in that would have scared the bejeebers out of me. And because making 600 was nerve-wracking enough, the first 600 of manufacturing something, because you don't know if those boards are going to show up from China and work. And in fact, ours didn't work.
Really?
They soldered everything together. The prototype, we made first we did like a 5-piece or 10-piece run before we ordered the 600 units. But the screen is with this very thin cable with a really fine pitch soldering connector, and they didn't tape them down. So after being jostled and shaking on a plane for 2 days or whatever, 80% of them were broken.
What do you do?
Well, again, we were just like, oh, crap. We're like, this might be game over, right? Because you don't have a lot of wiggle room. We just found a person in Portland that worked out of her house, and she was a full-time solder person. and we ordered screens. We just had to buy 600 new screens, and we told the manufacturer, this is a great story. We told the manufacturer what happened, and they sold us the screens at their cost, which surprised the heck out of us, because, we're some anonymous company on the other side of the planet. These guys literally sold us the screens at cost. And so we got all the screens, and we had to pay her, I can't remember what it was, like $6 or $7 per piece to solder screens on. So it was a big expense. Had that been 5,000 instead of 600,
just imagine,
it would have been a disaster. And so I don't think we would have been ready to just jump to China on our first go, right? The MRCC, we did it that way because we've had one experience of knowing where the problem spots are in manufacturing things, and there are many. That's a whole other hour-and-a-half discussion about how the trials and tribulations of going through manufacturing. Everything that can go wrong will, and things that you can't even imagine that could go wrong will. Our first manufacturer threw away as many enclosures as they delivered to us.
Oh my God.
Because they couldn't figure out how to make the edges of the enclosure not sharp enough to cut your finger. What? Exactly. It's like, dude, we're making a product to sell. And I literally said to the guy, it's right when you can drag it across your son's face and it doesn't slice his cheek. That's when it's that's when it's smooth. It's like you have to tell a sheet metal or whatever manufacturer that having it that sharp for a product isn't viable. We were just surprised completely by and that was just one example of probably half a dozen or more things that you wouldn't expect, that you had to tell that manufacturer how to specify the roundness of the edges.
But then you started working with what's his name, Gordon.
Yeah, in China.
Then it basically changed because
no, he had all the same problems.
Really?
But the manufacturers were in China, and then it was Chinese to Chinese, and we weren't involved. But they're still throwing away. And the reason why we don't have 1,000 MRCCs in stock right now is because of the enclosure manufacturer. This enclosure right here, it's a two-piece extruded aluminum enclosure, and they machine the face and then silk screen it, and then it slides together.
Yeah. Just imagine the amount of waste.
Yes, it's unbelievable. In fact, when they screw something up, like if they just there was a step in the process that the guy did not put them in a bag or between bubble wrap.
Yeah. He
literally just piled up 1,000 of these things. And of course the ones on the bottom are going to get scratched and dented.
Yeah.
And they did. They did.
Did you think about just using PCBs for the interface like Make Noise and other companies do?
Yeah, we sure did. It's all about what tools you use, right? So Pads, which is the application we're using for PCB design, is like this $10,000 a seat program that we managed to get the company to give us a license for $1,000 a year. Partially because Paul, the guy that we talked about that's helping us do the PCBs, is fluent in that, and we wanted to make his life as easy as possible. But also we started on what was that? What's that CAD program that people are using? Not the KiCad. We tried KiCad, and the problem with the footprints not matching the devices correctly, it was just there's a large ramp on learning how to use a PCB layout tool.
These are not the most intuitive tools.
No.
When I started playing with, I tried KiCad and I tried a bunch of other, and then I played with Easy EDA, and it was the only one that I felt like, well, they sort of learned some things from Adobe. But the rest, it feels like they did not look at Adobe programs at all. And it's like Adobe did all this research already, just like copy paste. all the there is no need to invent anything here.
Exactly.
It's really frustrating. So I yeah.
We literally couldn't figure out how to make a faceplate in pads.
Right. So that
we
is
just couldn't figure out how to put a graphic on the schematic.
Right.
Believe it or not. You can in what's the one that you talked about?
I'm using now Easy EDA. Yeah,
and I think seems like it's
I think for educational purposes it's perfect. I know that some engineers would say this is too weak of a program to work with, but at the same time, I know some advanced engineers that would say, you could actually do great things with it.
Yeah.
It's always a problem with footprints. Yes. But I felt like they actually did a pretty good job with you creating your own library. So it might take you a couple of hours to just find the right components. Right. But once you have these, then you should be able to just design things with your own library. It's like you're creating your own little template, and then you don't really need to deal with a billion different components and pitch sizes they have.
Yeah, and Daryl did the same thing with pads. He basically now
I can imagine
we have our library of components that we use, and he uses that as our starting point.
Yeah. So but I know a few people in the community that do this actually pretty well. Mm-hmm. So yeah, I can probably connect you with a couple of people to just experiment with it, because it feels like it might be a better way of prototyping. Also, it's dirt cheap. It's much cheaper, and you can do a lot of really interesting things with light, because it's a translucent material. You could create really beautiful light effects and minimalistic designs just because of the material, and it's dirt cheap.
Yeah.
So if you're making mistakes,
Daryl is a large make noise fan, and we've another thing is our user interface design, which we didn't talk about, is we have a bunch of gear, and we literally take it apart physically, and we also take it apart, design wise, and we see that there's piece. Yeah, we love the idea. We were heavily weighted towards doing a PCB interface, and we literally couldn't do it. That's why
is so frustrating.
That's why we're in a aluminum enclosure. Yeah, the original Noodler probably would have had a PCB faceplate had we been able to figure that out.
Well, I see that you're working on a bunch of new stuff there, so maybe now with the community you might be able to reach that goal.
Yeah. Well, yeah. I mean, just to use Easy EDA for the faceplate and not for the board design is
no, I don't think that people use Easy EDA for that. But I know that they are using KiCad, and I'm going to connect you with a Discord community, and I think that you can get some people there to help you with that. But this conversation was amazing. Thank you so much. I really appreciate how generous you were with explaining everything. I'm sure that people are going to really appreciate it. And I'll see you online.
Okay. Thank you so much. I appreciate it.
Thank you.